In manufacturing domain, there is a large amount of data getting created with respect to manufacturing of various products. So we can use data science and AI in manufacturing for predicting the quality of the product which is manufactured. Then we can also use data science and AI for predicting the maintenance needed for the machines. Because what happens in manufacturing company is you have a large number of machines which are placed one after another, and if one of the machine goes down, whole manufacturing pipeline stops working. So it is very important to predict the need of maintenance ahead of time to avoid such issues and to avoid loss of output with respect to that manufacturing plant. Hi, my name is Rohit, and in today's video what we would do is, with respect to manufacturing domain, we would develop a machine learning model which would predict the quality of the item or quality of the product which is manufactured from that particular manufacturing plant. So let's build this model. So at the top, I'm importing all the packages and modules that we need. So we would need pandas, numpy, then seaborn for the visualization along with matplotlib. And then I'm importing other libraries or other functions which are related to the machine learning model development. So the data that we have is related to the quality rating prediction of the product which is manufactured, and the features that we have are as per following. So we have the temperature information. So this would tell us what was the temperature during the manufacturing process, because temperature is very important parameter in determining the quality of the product. Then the second information that we have is pressure. So this would tell us what was the pressure which was applied during the manufacturing process. Then we have a derived parameter, temperature into pressure. So this is just the multiplication of these two values, temperature into pressure, and this basically captures the combined effect of these two process parameters with respect to manufacturing. Then we have material fusion metric. Again, it is derived from temperature and pressure. It is calculated basically as the sum of square of temperature and the cube of pressure. So this is how this particular parameter is calculated, and it represents material fusion related measurements during the manufacturing process. Then we have material transformation metric, which is calculated by considering the cube of temperature and subtracting it from square of pressure. So again, this is a derived parameter, and it is insightful to understand the material transformation dynamics during the manufacturing process. And the last column that we have is the quality rating. So this is basically our target variable. This is the variable, or this is the column that we are going to predict using the machine learning model. And this quality rating represents what is the quality, what is the overall quality or the quality rating that particular product is getting. So basically, whenever there is a manufacturing going on in any manufacturing plant, every product goes through the quality inspection process, and then based on the inspection of that product, there is a quality rating given to that particular product. Now let's imagine that there is a factory which is, say, manufacturing lakhs of product on a daily basis. So it is very difficult to verify every product. So, and the quality of the product is dependent on the manufacturing process. So if you build a predictive model which is based on the manufacturing process parameters, is able to predict the quality rating of the product which is getting manufactured, then that would create a huge value for the manufacturing industry. So that's what we are going to build over to in this particular project. So let's get started. Okay, so this is the data we have. We are reading the data from the CSV file, and then I'm just printing the top 10 rows using head function. So we have information about temperature, pressure, then temperature into pressure, material fusion metric, transformation metric, and quality rating. So we discussed all these parameters already. So let's go ahead and explore the data. So using dataframe.info function, you are able to get information about all the parameters or all the columns in that particular CSV file or in that particular data frame. So here we can see that these are all the columns which we have, and we have around 4000 rows in this data set, and everything is basically having non-null values. So it seems that is in this data we don't have any missing values. Then if you apply describe function on a data frame, it would give you various numerical calculations with respect to every column. So if you check, for example, temperature, The minimum value of temperature that we have is 100 and the maximum is 299.99, so around almost 300 degrees Celsius. Then pressure is ranging from 5 kPa to 24 kPa. Then similarly for all the parameters we are able to get the values. So this data exploration stage basically helps you in understanding the data, how the data is distributed. And if you see the quality rating, this is the variable that we are going to predict. The minimum value that we have is 1 and the maximum is 100. So right from 1 to 100, we can get any quality rating for the product that is getting manufactured. So here I am creating a histogram of the quality rating column, and in that I am giving 20 bins and the color of the histogram I am keeping as blue, and this is how the histogram will look like. So if you see here, most of the products are in the bin 95 to 100. So most of the products which are manufactured are high quality products, but there are some products which also have low quality rating, and these products when they go out in the market, obviously they would create a lot of issues for the manufacturer. So it is very important to predict their quality based on the parameters of a manufacturing process. Now let's check the null values. So using data frame name .isna.sum, we are able to check the null values. So we don't have any null values or we don't have any missing values in this particular data. Okay, so now I'm creating the plot for detecting the outliers. So for detecting the outliers, or you can say potential outliers, we can use the box plot. So we are creating the box plot using Seaborn. So here what we are doing is, first of all, we are creating the subplots with 2x3 matrix. So basically we can create 6 plots in this. And then we are passing every column one by one: temperature, pressure, then the temperature into pressure column, material fusion matrix, and the transformation matrix. So if you see here, these are the plots we are getting. So this is how the temperature is ranging. So the median value for temperature is around 200. Then for pressure, the median value is around 15. And you see that potentially we don't see many outliers. So in temperature into pressure, there are some potential outliers, but still the number looks very small. And whenever you see any numbers which are going above this range or below this range, right, or any data points, those are potential outliers. Those are not like definitely outliers. So you should always validate them with your business to understand whether those are actually outliers or not. So in our data, we don't seem to have any outlier problem. So all the features that we have are numerical features. Okay. So let's check the correlation between the features by plotting the heat map, and to that heat map we are passing the correlation matrix. So this is how the correlation matrix is looking like. So if you see features like material fusion metric and material transformation metric, they have very high correlation with temperature, 0.97. Then between material transformation metric and material fusion metric, we have 0.98 correlation. So we have some features which are highly correlated. Now, if you are trying to build models like, say, logistic regression, then this highly correlated, or linear regression, then the highly correlated features might impact the results that you have. But for tree-based models, even if you have highly correlated features, you can still be able to handle those. And another thing is to make conclusion between which of the features to be dropped between the highly correlated features. Usually, I would recommend you to drop the features which don't have causal impact on the output. So if there are some features which are main reasons for driving the output, then obviously those features should be kept. And if there are features which are having mere correlation with some of the features, then you can drop those. But in this case, we don't have any domain knowledge, so we don't know, say, out of material fusion metric and material transformation metric, which of the features we can drop. So in this case, when you are not clear which features can be dropped and those are highly correlated features, then I would say it is okay to keep both the features and then build your model, and then based on the model you can decide which of the features you want to keep. So we are going ahead and keeping all the features, but we have the knowledge now that we have highly correlated features. So when we go at the feature selection stage based on the feature importance, we can use this knowledge and drop some of the features. Okay. So the numerical features that we have are temperature, pressure, temperature into pressure, material fusion metric, and material transformation metric. So we are now going to split the data into training dataset and testing dataset. So for that, I have written a function here, train test split data, and we are just calling that function over here. To that function, we are passing our data frame, which has data regarding features and the output value to be predicted. So we are creating a y variable, or we are creating a label column over here, which would have our quality rating. Then for our feature column, we are just dropping this quality rating because we don't want to use the value to be predicted as our features. So we are just separating our y and x variable. Then over here, I am just storing the list of all features which we have. And then using train test split function within scikit-learn, we are just separating the data into training dataset and testing dataset. So I am passing test size at 0.20. So basically we want to use 80% data for training, and we would keep 20% data for testing purpose. So we are then getting our training data frame and testing data frame along with the corresponding labels. So we are just returning all the values over here so that we are able to get all those return values in these variables. So this is how our training data is looking like. We have 5 features in total, and all the features are in the numerical format. Now in this stage, suppose you want to build a model like linear regression for predicting this numerical value of quality rating, right? Then I would recommend you to definitely use some form of scaling before you go ahead and build the model. What I have done is I have not used linear regression model. So I have basically used XGBoost model. So I don't have to use any kind of a scaling, because XGBoost is the tree-based models, and for tree-based models you don't have to use any form of scaling. Okay, so what I have done here is, first of all, I have defined the parameter grid. So I am going to try all different sets of parameters on my XGBoost regression model. So the parameters that I am keeping: learning rate, I am keeping 0.1, 0.2, 0.3. So learning rate in case of XGBoost model basically decides what's the contribution of every subsequent model that we are building in XGBoost. Because when you build XGBoost model, you are building models one after another, and every next model is trying to improve the errors caused by the previous model. So this learning rate decides what's the contribution of the next model in the overall result. Then the max depth decides what's the depth of the decision trees which are built in the XGBoost model. So we are going to try depth 3, 4 and 5. Then we have subsample information. So subsample decides what's the percentage of data we are going to use in every decision tree which is getting built in XGBoost model. So I'm keeping 80% and 90%. So passing 0.8 and 0.9 over here. Then call sample by tree. So this decides what's the percentage of features we are going to use in at every decision node. So again, we are using 0.8 and 0.9. And number of estimators. So we don't have a huge data, very small data that we have. So I have kept the number of estimators as 50, because sometimes when you use large number of estimators, when you have small data, there is a chance of overfitting. Okay. So we are initiating the XGBoost regressor model over here, and then we are using the grid search CV function from scikit-learn model selection. And to this function, we are passing our model. Then we are passing our parameter grid, which we have defined over here. Then we are passing CV equal to 5. So basically we are going to use 5-fold cross validation, and the scoring mechanism we are passing is the R2 score, because we are going to build a regression model. So we would use the R squared score for evaluating the performance of the model on different parameters, so that we can find which parameter set is giving us the best results on this particular data. So if you see here, you would see bunch of outputs over here. So basically, if you see these 5 selections, cross validation for set 1, set 2, set 3, set 4 and set 5. So what happens in case of a cross validation is your training data is divided into 5 sets, and in every iteration 4 data sets are used for training, and one of the data set is used for evaluating the model. So this is how in cross validation you are using different sets of data for training and evaluating in every iteration. So if you see here, for 5-fold cross validation, we are getting the results for every set of parameters that are tried. So I won't go through this because it is a bit unreadable. What you can do is, once you run this particular function, or once you run this model training part, you would be able to get results for all set of parameters into CV results variable within the grid search that we are initiating over here, grid search object. So what I'm doing is I'm storing that result into data frame, and then we are just sorting the result based on the mean test score. And we are keeping ascending false so that we get the best result at the top. Okay, so if you see here, so there are a couple of parameters for which we are getting very high result. So the mean test score that we are getting is almost 0.999. Then we also have some other parameters for which the results is still good, but bit less than the top result that we are getting. Now, if you get these kind of results for various sets of parameters which are tried, so in this particular data frame, if we go here in column params, you would see that various combination of parameters are tried on this data. And then for every parameter, we are able to get set of results. So if you want to get the best parameters, you can just use the best params variable from this particular object that you are creating. So we are doing search best params. So the best results that we got on this particular data set were based on these parameters. So call sample by tree 0.8, then learning rate 0.2, max depth 5, number of estimators 50, and subsample 0.8. So we have found that these are the best parameters on this particular data set after doing hyperparameter tuning. Now what I am doing is I am now training the regression model on complete training data set that we have, and to this regression model now I am passing the best parameters that we have got. So these are the best parameters which we got, and I am just passing them over here, and then I am training the regression model using fit function on the whole training data set that we have. And then in XGB predict, we are storing the prediction of the model that we have trained. So here we are passing the test features, and based on the model that we have trained, we are predicting the value and storing it into XGB predict. Then after that, we are calculating the R squared score or R squared value. So for that, you have to pass your label along with your prediction. And if you see here, the R squared value that we are getting is 0.999, which is very high value. So we are able to predict the quality of the manufactured product, you can say, with a very high confidence, with a very high accuracy. And in terms of the error, the mean absolute percentage error that we are getting, again you can calculate it using a function. To that you have to pass your label and the corresponding prediction that you have. The percentage error that we are getting is very small, 0.001. So we are able to predict the quality of the product which is manufactured based on the manufacturing parameters with a very high confidence or very low error. Okay, now what I have seen is most of the people who are learning data science for the first time, they stop over here, but they are not able to trying to understand which features are actually driving these results. So what you should always do is go ahead and try to find the important features. So for that, in the XGBoost model, you can use the model.featureImportances parameter, and that would give you importance score of every feature. And this importance is calculated based on how that particular feature is used during building decision trees behind the XGBoost model. So over here, we are just storing the important score that we are getting from features into a data frame. We are just naming the columns so that they become more readable. And then we are sorting the importance scores simply and printing all the importance scores. So in this case, we have only 5 features. So if you see here, this is the importance that we are getting. We have kept the importance in ascending order. So the lowest importance is given to feature pressure. It is 0.000047. And the highest important feature that we have is temperature. So it has 0.70 feature importance. Then material transformation matrix, it has 0.29 feature importance. So if you see here, basically material transformation matrix and temperature, these two features are completely driving the results of our regression model. And the remaining 3 features are having very small feature importance, or you can say very small contribution in our overall result. So if I plot the feature importances using matplotlib, this is how the graph is looking like. So temperature and material transformation matrix are the features which have very high importance, and remaining features have almost 0 importance. So they are not contributing to our overall result of prediction. So what you can do in this case is, if you have features which are having almost 0 importance, you can drop those features. You don't have to use those features in your machine learning model, because those features are anyways almost not getting used. And there is no point in building complex machine learning models. So whenever you use a large number of features in any machine learning model, that is making that model complex. And if those features are not bringing in any intelligence, why to use those features? So what I'm going to do now is I'm going to drop these remaining 3 features, and we are now going to build a machine learning model using only temperature and material transformation metric, these 2 features. And let's see that using these 2 features, can we still get the results, the kind of quality results that we were getting. So what I am doing over here is in our training feature matrix, I am taking only 2 columns, temperature and material transformation metric. And in our testing feature matrix, again, we are taking only those 2 columns, only those 2 features which were very, very important in this case. So remaining features, they are almost having 0 feature importance. So that's why we are dropping those features. And then I'm retraining the model over here using those 2 features, and I'm keeping the model parameters as the same. So whichever best parameters that we got after hyperparameter tuning, I'm using those parameters itself for training this regression model. And then we are just predicting the result after doing training on this new data set. So if you see here, the R2 score that we are getting now is still 0.999. So we are still able to get very high quality result along with very low error even after we are using only 2 features. So this is what I would recommend you. If you're having features which are almost having 0 importance, you can drop those features and make your machine learning model less complex. And after using that less complex model, if you're still getting high quality results, that's the really great thing. So if you see here, I'm checking the feature importances again based on the new model that we have built. So over here now, if you see, temperature is having feature importance 0.608 and material transformation metric is having feature importance 0.391. So just based on these 2 features, we are able to build high quality model which is able to predict the quality of manufacturing, quality of the product which is getting manufactured through that particular plant based on the various manufacturing parameters. And if you see here, right, we were having issue with some features having high correlation, but we went ahead with it. We still built our model, and after building the model, we are able to find a way to drop the features, and then we ended up basically with just 2 features which are able to predict the quality. Okay, so I hope that now you got good clarity in terms of how we can build regression model using XGBoost and specifically use that in a manufacturing domain. Because in manufacturing domain, one of the main reasons or one of the challenges that manufacturers are facing is the quality of the product. So if the quality of the product which is manufactured is not good, then that creates a lot of loss for them. Now let's imagine that based on these parameters, if you are able to predict quality of the product, maybe you can also predict what is the optimized parameters with respect to temperature and pressure to get high quality product as the output. And those parameters maybe then can be used by the manufacturers for making sure that their manufacturing pipeline is set in the right way. Now go ahead and try to build products or try to build projects using other datasets on Kaggle related to manufacturing domain. And specifically, if you are someone who has working experience in manufacturing domain and now you are trying to transition into data science, I would definitely recommend you to build at least 2 projects related to manufacturing, because when you apply for data science roles in manufacturing company and you already have experience in that domain, you would definitely get the advantage. Thanks for watching the video, and I will see you in the next one. Bye bye.